Grüezi YouTubers, here is the guy with the Swiss accent. In video number 115 we built a proper but expensive LoRa gateway, and in video 124 we built a single channel but cheap gateway using a Raspberry Pi and a Dragino hat. Today we will build a LoRa gateway which costs only around $15, antenna included. And it is so small it fits in the palm of a hand. Please watch video number 124 for more information and for the limitations of single channel gateways. This gateway, other than the one in video number 124, even offers a downlink capability. So let's start. First, what do we need to build this gateway? As usual, we need a LoRa module. In this case, a Hope RFM95W. In addition, we need a PCB where we can mount the parts and connect it to the Wemos Mini. Fortunately, Charles Allard did a great job and created such a PCB, and we can order it from here. It has the same size as all the Wemos shields of video number 106, and it gives home to the LoRa module, to a small OLED display and some other parts. These parts are all 805 SMDs, but I used 1206 SMD capacitors and even bigger diodes, and they also work. Maybe they do not look very nice. In addition, we can also put two Neopixels on the board for a small light show. However, they are not necessary. Also, the OLED display is not necessary, but I think it's really a nice feature. So I started with the top side of the PCB and soldered the RFM95W, the Neopixels and two capacitors using my Aldi reflow oven. You can also solder this part by hand, as I did it with the bottom side. On this side you have to add another 3 capacitors, 2 pull-up resistors and 3 diodes. The purpose of these diodes is not clear to me, so I just added them without really understanding. But I had to remove the 4th diode because the gateway did not work properly with this diode in place. As a last part, we have to add the SMA antenna connector. Here you can just add a piece of wire with the right length for your frequency, if you want to save the money for a proper antenna. At the end, I added the 2 pin headers to connect the PCB with the Wemos board. If you pay attention, you can make it compatible with the other Wemos shields. Of course, I discovered that only when it was already too late. Just a remark. This PCB uses pin D1 and D2 for the display, the same as the Wemos display shield. But you can mount the display also directly to the PCB. The layout fits the Heltec SSD 1306 boards. I also added a female pin header for the OLED display, and now I'm ready to go. You can use the original library if you want, but I added support for the OLED and some other small changes. So if you want to use a display, use my library. Before we upload the sketch, we have to enter the Wi-Fi credentials and also change the address of the TTN server. You find a link to all the addresses in my new blog. At the beginning, we leave the debug flag on to see what happens. Later on, you can set its value to 0. Fortunately, the pin definitions are already okay and we can upload the sketch. The gateway connects to Wi-Fi and tries to connect also to the TTN network. But here we first have to register the gateway. We do this by selecting Packet Forwarder and by copying the gateway ID from Serial Monitor to this field. Then we add a description and select the right frequency plan. You can also enter the place of your gateway if you want. And after a while the status should show connected. If not, wait till you send your first message to your gateway. Now you can try to send your first message via your new gateway. Just be aware that you just built a single channel gateway. And this means that your gateway only listens on one channel. If your node sends its messages on other channels, your gateway will not get it. This is why you have to restrict your node also to just the channel your gateway listens. For details, watch video number 124 and read the blog. From now on, we can monitor our traffic which is transferred via our gateway. If a message arrives, the LoRa Neopixel blinks and the display shows the time of the message, its RSSI, SNR and the length of the message. Very neat. Unfortunately, I was not able to show you also the content and the sender of the message. Do you know why? Perhaps because it did not fit to this small display? No, not at all. Actually, this is good news, because these data are encrypted and nobody can read it. Only you in the backend, because you know the key of your LoRa node. So you cannot play NSA or CIA on other people's messages. At least not without a lot of effort. And if you build your LoRa shield as it should be, compatible with the other Wemos shields, you can even use some of the standard shields like the display, the battery and the power supply shields. So summarized, we were able to build a very small LoRa gateway, and it even supports downlink and OTAA. All parts together do not cost more than about $15. Because it works with an ESP8266, we even have a wireless connection to the internet. Of course, it is only single channel. But because it's so cheap, why not build 2 or 3 of them on different frequencies? The build was very easy because we were able to use a ready-made PCB, which is compatible with the Wemos shields. The optional Neopixels and the OLED display show us the traffic, but not the content, because it is encrypted. I hope this video was useful or at least interesting for you. Bye!